This is the fourth notes for vectors. Up to this point, we have used a lot of special right triangles. The special right triangle train is not going to happen in this section, or at least it's not going to be prominent. Given a vector in component form, find the vector's polar form. To find the polar form, we need the magnitude, left out a letter. We need the magnitude, and we also need the angle. So for number one, well, let me just tell you a big picture. To find the magnitude, you can just use this formula blindly, which I don't recommend, or you can think about in your brain how it's formed each time. To find the magnitude of a vector, you're going to take the square root of the sum of the x and y components. To find the angle, you're going to take tangent inverse of the y over the x. Now, a word of caution here for this angle. Depending on the situation, this angle might give you theta prime. And actually, in most cases, well, let's just leave it at that. We're going to use this to help us find the angle. This is either going to give us theta or it's going to give us theta prime. Depends on the situation. We'll examine the problems and figure this out. But essentially, we're going to use tangent inverse to find the angle. We're going to use the distance formula to find what the magnitude is. So let's see if we can check out this problem and see if we can make sense of it. Vector v is in quadrant 1. We're supposed to go to the right one and up to, here's vector v. If we make a reference triangle, like we're going to always do, we're going to the right one, we're going up to find the magnitude, it's the Pythagorean theorem, solved for the hypotenuse. The x component of this is 1. The y component for this is 2. So that's going to be 1 plus 4. It's going to be the square root of 5. So the magnitude of this vector is square root of 5. Now what about the angle? So in this case, the angle is going to be just tangent inverse of 2 over 1. Here's the reason. If we take tangent of the angle, it's the opposite leg over the adjacent leg. Therefore, tangent inverse of 2 is going to be what theta is. If I put this into a calculator, tangent inverse of 2, assuming that I can write legibly enough that it knows what I'm asking, that's going to give me this angle. It's about 63 degrees. We're just going to round to the nearest whole number. So if I wanted to figure out where this point was in the coordinate plane, I could go right 1 and up 2, or I could have a radius of square root of 5 and then rotate that in this direction 63 degrees and put me at the same point. Let's check out number 2. This is going to be in quadrant 3. So we're supposed to go left 4, down 6. We got this point. Draw a vector. This is going to be vector u. Make a right triangle using a reference angle. Now, it should be noted here that we are going to be finding theta prime first. We got to actually figure out what theta is. We went left 4. I'm sorry, this is going to be in quadrant 2. I fudged up, kids. Left 4 and up 6. We're going to find theta prime. That's not likely to give us the correct final answer, but we'll see what happens here. So let's figure out what the magnitude is. Magnitude is the distance formula. It's the Pythagorean theorem. It's the x squared plus the y squared, and then you square root them. Please note this negative needs to be in the parentheses, because if you square something, it becomes positive. That's going to be the square root of 52. We could reduce that to 2 square roots of 13, but we'll just leave it like this. We don't have to get all crazy. So the magnitude is square root of 52. Now what is the angle? So if we do tangent of theta prime is the opposite angle, is the opposite leg over the adjacent leg, we're going to get that this is 6 over negative 4. Let's see what happens. Will this give us theta prime, or will this give us theta? We'll figure this out, and then we will adjust this accordingly. So tangent inverse of 6 over negative 4. Now that says negative 56 degrees. You got to be really careful about this. Negative 56 degrees. That's in quadrant 4. Negative 56 is in quadrant 4. That's down here. This is clearly in quadrant 2. So here's what we might want to do instead of what I just did. I'm going to go back in time, try to make this easier for us. Let's take the angle that we're given here, and let's draw this triangle ignoring the negatives. And let's just say that it's 4 and 6. And this is going to give us theta prime. So tangent inverse of 6 over 4, we should get 56 degrees, I believe. Oh, this is awful. There we go. So if we do, once again, tangent of theta, 6 over 4, theta is tangent inverse of 6 over 4, theta is 56 degrees. This is theta prime. It is the reference angle. So if this is 56 degrees here, this angle that we're trying to find, theta, is going to be 180 minus 56. That's going to give us 124 degrees. So once again, what does this mean? This means that we could find this location in the coordinate plane in one of two ways. We could go left 4 and up 6, or we could go square root of 52 and then rotate that 124s and get to the same spot. A vector is a magnitude in a direction. The magnitude is square root of 52, and the direction is 124 degrees from the standard position. Check out number 3. This is going to be in quadrant 3. We're going left 5. We're going down 7. Make a reference triangle. We're going to figure out what theta prime is, and then we're going to add that to 180 to figure out what theta is in this case. To find the magnitude of vector W, it's the square root of the x value squared plus the y value squared. It's going to be 25 plus 49. It's going to be 74. So W in polar form is going to be square root of 74, and then we're going to have whatever angle we get. Now to find this angle, we're going to use this triangle. We're going to ignore the signs for now. So we got 5 and 7. Tangent of theta prime is y over x. Theta prime is tangent inverse of 7/5. I lost my calculator. Tangent inverse of 7/5. It gives us 54 degrees, approximately. So what that means for us, this angle right here is 54. So the angle in standard position is 180 plus 54. So theta is going to be 180 degrees plus 54 degrees. So that's going to be 234 degrees. The magnitude of this vector is square root of 74. The direction is 234 degrees in standard position. Vector S is in quadrant 4. We're going 10 to the right and 2 down. Let's figure out what theta prime is. And then we can figure out what theta is. Let's also figure out the magnitude. The magnitude of vector S is the square root of the x value, the x component squared, and the y component squared. Add those together and square root them. That's 104. So the magnitude of this little fella is the square root of 104. We could simplify that, but let's not focus on that right now. To find theta prime, we're going to do tangent prime is the y over x value, and we are doing this, we are ignoring the sign, we're ignoring the signs because we want to find the reference angle first. Then we'll worry about the actual angle. So theta prime is going to be tangent inverse of 2 over 10. Put that in my calculator. I'm going to get theta prime is about 11 degrees. Now, if you see where this 11 degrees is, in standard position, that's 11 degrees short of 360. So in this case, theta is going to be 360 degrees minus 11 degrees. I left off my 0 in 360. Oh, bother. So that's going to be 349 degrees. Vector S has a magnitude of square root of 104 and an angle of 349 degrees from the standard position. Now you could have also said, well, I want this to be square root of 104 and negative 11 degrees. The same answers, because these are coterminal angles.